Please give him a warm welcome, Bodo, Kaiser.
Hello, my name is Bodo, and I'm going to talk about Websockets. And first, a small joke to make an introduction. And now let's go on to the topic. Then he will look like this.
Oh, yeah, exactly.
Okay, so WebSockets. Who from you have already used WebSockets? Or okay, and who from you use Socket.io? And also someone who used raw WebSockets? So the reason how I got into the WebSocket protocol, I think it was 2011 or 2012 somewhere. Socket.io was around, but it always used HTTP as fallback. Maybe someone knows this problem. I think they solved it now, but it was quite annoying because I want to use WebSockets because I want to use WebSockets and not to use some ugly Ajax fallback. So I thought, okay, can't we do this better? And it took me maybe 1 or 2 months, and I got out the Bible. And the WebSocket Bible, you find it when you Google RFC 6455. And in this text document, they really define every small part of this protocol. And it really helped me to just read through it. It's not written very complicated, but you get a good overview from every part of the spec and a bit also how to implement it. And this is also the topic about today's evening, how you can implement this protocol yourself. So I hope maybe not practically, but you have an idea and how you could theoretically implement this also yourself. So the WebSocket protocol are 2 parts actually. The one is actually the HTTP part and the other is the WebSocket part. The HTTP part is quite common, so here we have a simple HTTP request response pair. And we also have the WebSocket type. And we first start with a request from the client which says I want to upgrade, I want to have a WebSocket connection. And the server then responds that this is possible and maybe some meta information like what extensions do we use. And then the socket, so as you know, in HTTP we actually just write strings to TCP sockets. The socket from these HTTP connections is kept open for binary data. So if we want to implement this protocol, we need to know how to make the HTTP handshake and how to parse the binary data. So let's look how the upgrade is built. This is how the HTTP stuff looks like. And the most thing is actually quite common. The things which are strange or new are these 2 headers. Very interesting also why we need to use here uppercase. Yes, and then we also have the sec WebSocket accept header, the version, and the protocol. The protocol is actually just some meta information. It's not really necessary, so we can omit this. The version is necessary. It's version 13 is actually the standard, and accept is just some string which is random generated. And the server response is 101 status code, also again with some mixed cases and with some accept header where we take the WebSocket accept key, and also if we support the protocol. So one idea for the protocol thing would be maybe we use a custom protocol in our WebSocket application for chatting. We could, for example, write here chat or something else, but actually it's not so necessary. And yes, so how does the key, for example, look like? It's, I think, a 16-bit string, which is randomly generated. Then we also have this GUID. We've also find this GUID over here. Here. So it's just a constant string which we need to implement into our application. And yes, and the key is from the client randomized. So what we do is we take the key from the client and also the GUID, which is on the server as a constant string. We concat them, then we hash them, and then we encode both as base 64 and send it back. And the client has so a possibility to validate if we are really supporting the protocol and if we can be trusted. So because the slides are nice, but practice is better, I also want to try to...
Can you increase font size?
Yes. Oh. Okay, so because we are need the browser implementation of the WebSocket, so the browser has a WebSocket client built in. I just start with a standard HTML file, which we then will serve over Node.js. So I think this is nothing too fancy now.
Crazy thing about Node, you just go and build yourself a website.
How much lines would this take in Java or C++?
You mean how many files?
And how long would the build take?
Starter side.
Also this. So. So,
One line of code. So like a dozen.
okay, so this works now, and I hope you also all know supervisor. So we now just we don't need to restart the process extra. So everything works now, and we can now, for example, create here a WebSocket connection. I think this looks somehow like this. Yeah. We expected something like this. Yeah.
This is Flash.
Yes. And because you just were concentrated on the slides, we know we didn't implement any handshake, so this is the expected result. And the reason why I use the browser as a WebSocket client is because it also supports the standard, and implementing the client is quite more difficult than the server, I think. So let's start editing. Nerd tree, must have. And let's implement the handler for the upgrade. The HTTP module from Node has an extra event for the upgrade, and we get the request, the socket, and I think also some bytes. And let's check if this works. So, okay. Not good. Yeah. So we should now, if we try this again, we get this logged here. And here we should somewhere get a timeout, because what now happens is the HTTP parser in Node triggers this event, and this handler is executed, and the socket is left open. So the other case was just that the request handler would be invoked. So as we saw in the slides, we now need to get this response to the client, and so the client just knows what to do. And we can do this by are these stringleters actually supported in Node? Does someone know this? Yes? Okay. Okay. Oops. So let's look for the so we now can also look in into the RFC. You see there are the different headers explained, because I have some problems just copying the string here. Then I have another idea. I just don't want to, I don't know this. Ah, yes. So, okay. I hope this works. Muss RN? Okay. So what should I do?
Remove the /n. Don't leave them in the
Okay.
ECMAScript 6 string templates.
So this should also work?
Yep.
Okay.
The last one you should leave.
Okay. Thank you. Collaborative coding. So let's look what happens.
Das ist
Okay. For some reason the client doesn't.
Template Strings. Diese White Spaces von der dritten Seite.
Okay.
Ja, die müssen auch weg.
Echt?
Ja. Kriegt ihr alles weg.
Aber dann sollte auch zumindest das Konsole-Log da ausgeführt werden.
Wahrscheinlich müsste es auch mit selben Zeile oben anfangen.
Ja,
Sonst
genau.
ist die New-Line am Anfang.
Ja.
Wozu hat man dann die überhaupt?
Ja, genau.
Ja.
Okay.
Und am Ende auch.
Und am Ende ist so wie wurscht.
If this not works, we do it old school like.
Kann es sein, dass er, weil da schon irgendwelche Websockets instanziert sind, dass er keine neuen macht, dass er die Seite erstmal neu laden muss, dass er die alten migrieren?
Habe ich ja vorhin schon.
Das ist geschummelt mit Taschenrechner.
Okay, there is something strange going on. I try last time, else I just show the slides.
No stack traces at all. Do that in Java.
Probieren einfach das Tab zu schließen und zu öffnen.
Okay.
Also ich probiere mal noch irgendwie so eine Klickung Websocket.
Auch wenn man das reloadet.
Wahrscheinlich.
Okay. So, thank you. Okay, let's go back to this here. And we got the trick. It's just completely closing the tab. Okay, so we see sec WebSocket accept header value is wrong. And this we also just expected because we just took this from Wikipedia and didn't generate it ourselves. So how do we generate it ourselves? We take the globally unique identifier, which is also in Wikipedia, and now I just need Wikipedia for implementing protocols. So, okay, and now we
That's globally unique.
is it headers or header with S or without S? Does someone know this?
S is an object without is
Okay, so if I want to do
yeah, like that.
okay. Okay, undefined. I think they lowercase it. Yes. Ah, yes. Okay, good. So we now take this key. And we push the general unique identifier on it. And then we know to hash it. Let's just look how to hash this thing. If someone knows it, also not bad. I think it's here. Crypto create hash. Ah, here. Something we want to know. Yep. So. Does this work? Yes, huh? Okay. Okay. Yes, right. Okay. Yes. I need to take the cheat sheet, sorry. What do you mean?
Equals, kind of a separator, something like that. Is it there?
Yes, I have key plus equal. It just concats the string, or doesn't it? Yes. Okay.
You mean that there is a separator between the two?
I cheat. Sorry.
Now you're a pro.
Okay. So this should work. Yes.
Magic function here.
Cheating pays off. Okay, so we now got the handshake done, and we should also see somewhere here. Yes, we see the WebSocket thing is established. So we can now send data through it, but we will notice the data looks quite weird. So let's just look what we get when we send something. yes, we get this buffer, and now let's stringify it. Oops. Okay, so we can't do anything with this, so this is why the next slides come on. Yes, the frame protocol. So we now don't have any strings anymore, we have binary data. And a frame is just a sequence of bytes, and we have the head, which just contains information about the frame, and we got the payload. So the head has no constant size, it always depends. So in the smallest possible frame, it just consists out of 2 bytes. The first byte contains, for each, a byte consists out of 8 0 or 1s. And you can now find, for example, if the first 0 is a 1 or a 1. If the first place is a 0 or a 1, you can read information out of it. For example, you have, for the first byte, if the first place is really a 1, you have the reserved bit set, and this means, for example, your frame is invalid. And the next frame contains, for example, a marker, binary information, if the following data is masked. I will explain later what I mean with masked, and how long it is. Okay. Das sind aber nicht die Minuten, oder? Okay. Ich versuche mich zu beeilen. Okay, so as you know, because the first place of the second head byte is already gone, you only have 7 bits left to set the length, and this would leave about 200 bytes following or something. And this is mostly too small for a lot of data, so you can also extend the length a second time and a third time. For the second time, it reads then into a 16-bit unsigned integer, and for the third time, even into a 64 unsigned bit integer, which actually is a number too big for JavaScript. But I mean, we don't need to read all of the data. And then we also have the masking. The idea of the masking is that you have 4 random bytes, and go through each of the client payload data and just do some bit operation. And the idea is that, for example, you for example get this here and not plain text. It's a bit like some very, very basic encryption, you can call it. And yes, then there are also the opcodes, and here you see them all, what value they mean. So let's go more specific to the length. Depending on what value the length first byte has and the length segment out of there, I can also show you. There is some good illustration here. Yes, for example, here. This is how such a frame would look. For example, here we have the hello frame and how it is encoded. And there is also, I think, some example where we see what I mean with... yes, here. This actually illustrates it perfectly. So this here is the first byte, and for example, if this here, you can read then each of the places in the byte. So, and for example, the length byte depends if this length thing has, for example, has the value 7e, or is smaller than 7e, you just take the first byte as length and take the length value out of it. If it is equal to 7e, then you parse the upcoming 2 bytes, and if it is 7f, you parse the upcoming 8 bytes. Then the masking, this is the masking algorithm, the encryption algorithm, which you run through the complete payload. And yes, this also helps you then to encode the frame. So what we need to do is, I think this was also a problem last time. Okay, it doesn't want to. So, okay. What we need to extract is the masking, and the masking we should get after the first 2 bytes, or better we extract first the length. Let me think. Does someone know binary operations quite now? How can I extract the first bit? How can I subtract 0x8? Somebody knows this? Not? Then I also need to get a cheat sheet again. Here. This was it. I had the wrong data. So five, and we always send the string hello. So we have a payload of 5. And I know you already, it's taking too much time, so I will skip now the implementing part of the payload. However, in the original implementation I worked on, which you also find on GitHub, by the way, I used streams in Node to implement this parsing part. And I can also, it's also the thing where I now just got always the write out of it. And the idea of the streams, you know, probably is to not work on the complete data at all, but to work in it in parts. And this makes fully sense because, for example, when you send maybe a 20 megabyte image through Websockets, you would slow down the complete server if you would first save everything up and then proceed it at once. And by using streams, we can do this just part by part. So how to implement a more difficult transform stream, for example, if you want to do WebSockets, you just need some information first. For example, if we are the header information, then if we are actually at the moment in the head section of the frame or in the payload section, then also if we still need, for example, the first 2 bytes, we first need to save up the first 2 bytes to do anything. And also if, for example, the length is more than usual, And raw head is, for example, where we save the bytes. And also we need to keep track how much we already read. Because what also could happen is you get two WebSocket frames which are stuck together, and they are in one data flush of the stream. So you need also to separate them, which was quite difficult. And this is how the transform then looks. We just check if we have enough, if we have at least 2 bytes, because then we can read the information in the head, which tells us how much more information to read. And also, if we have, the head is longer, if we also have the length bytes, the additional, then we also just emit an error if some of the reserved bits was set. This is always helpful if for debugging purpose. So if we have, for example, a wrong frame and we get it into it, or the transform stream got lost of where it is in the frame, at some time it will get a reserved bit and can just abort. And then we just extract the information bitwise. So I have here some constants defined, and then we do bitwise operations to extract them. And yes, and in the end we just take as much from the payload as we have. For example, here I also implemented an error if we have a number too big for JavaScript. And in the last part, here we unmask the payload because the client always sends masked data, and then we just push this next, and then we could, for example, have a file write stream or something attached to it. And my experience is it has an awful API, so I understand that nobody wants to use it. It has very super clean code. This is my specialty. Even no one wants to use it. Code that looks always good. And it's very memory efficient. So my use case was really to send images from the client, about 50 megabytes, over WebSockets to the server. And for example, Socket.io buffers everything. So I wouldn't be possible to do this with Socket.io, even nowadays, because the WebSocket parser Socket.io uses would buffer up the complete frame, the complete 50 megabyte, and then just pass it on. And this would just be too much for an image. So what else do I have as an experience? I also got the experience when trying to support mobile devices. WebSockets don't work. And the reason is, it took me quite a while to get to the reason. I always thought the problem was on my side. The 3G carriers have a HTTP proxy which blocks a WebSocket on port 80. So you need to redirect your WebSocket on port 443 because this is encrypted and there can't be any proxy from the carrier. So this is the trick how you can make it usable on 3G. So thank you.